Hey guys, today we're going to talk specifically about similar triangles, and more importantly, we're going to talk about theorems that prove that two triangles are similar. It's going to be a lot alike or similar to when we talked about theorems for congruent triangles. So there's three special theorems for similar triangles, and I have given you a space in your new flipbooks to add. So add to them, find this picture. And on the front, you're going to write angle-angle similarity. And I'm going to point out to you here this symbol, the little squiggly symbol. That is a representation of the word similar. So this says angle-angle similarity. And all it's saying is that if we have two triangles and we know that they have two pairs of corresponding angles congruent, then we know that those two triangles are congruent. Similar. It's very easy to mix up the words similar and congruent. So these two triangles are similar because I have two pairs, 29 and 29 degrees, 76 and 76 degrees. I have two pairs of angles that correspond in the two triangles that are congruent to each other. We can also use side-side-side similarity. And in side-side-side congruence, we knew that three pairs of corresponding sides were congruent. Well, in this case, we know that three pairs of corresponding sides make equal ratios. That means if we write the fractions, they're all going to be equal. So I'm going to write small over big. I've got the smallest one here and the smallest one there, 2 over 10. I've got the middle one 3 and the middle one 15. I've got the biggest ones 4 and 20. And so we're going to check, do all of these simplify to be the same? They do. They all simplify to be 1/5. And so since all three pairs of corresponding sides create the same fraction, those fractions are equal, these two triangles are similar by side-side-side similarity. So we didn't even have to know anything about the angles. The last one is side-angle-side similarity, and it's very close to side-angle-side congruence. The angles have to be between the sides or included, there's that word again, included, between the sides that you're using. So we have one pair of congruent angles that are both 66 degrees, and we have two pairs of sides that make equal fractions. So we've got, I'm going to do small over big again, 4 over 16 and 5 over 20. And these things need to be equal, which they are. They're both equal to 1/4. So we have these two pairs of sides that make the same fraction with the angle between them being congruent. That's what side-angle-side similarity is. So again, make sure you've added these three to your flipbook. I've given you the pictures. Just add this information. So let's do a couple examples and figure out if we can say the two triangles are similar. So I'm still always going to be looking for things like the reflexive property and vertical angles. And right away I know that I have vertical angles in this picture. And I have another pair of angles that are shown to be congruent, Q and D. So I have two pairs of congruent angles, so that goes along with the angle-angle similarity. So these two triangles are similar by angle-angle similarity. So since they're similar, I want to complete this similarity statement down here. It's very close to a congruent statement, except we use this similar symbol, the squiggly. And so we name it just like we did with congruent triangles. Triangle PQR is similar to triangle PDE. So I have to name them in the correct order. Let's try another one. If you notice, you don't know anything about any of the angles in both of these triangles. So angle-angle and side-angle-side can't be used. The only way that we can show these two triangles to be similar would be to check to see if the corresponding sides make the same fraction. So let's check that. My smallest side is 7 over my small side 29. Middle side's 8 over my middle side 33. Large side is 12 over 52. So the quickest way to check if these are similar would be to just put them in the calculator, see what decimal they come out to be. If they're exactly the same, then these are the same fraction. So I got my calculator out. I can do 7 divided by 29. Oops, I think I made a mistake. 7 divided by 29 is 0.2413. 8 divided by 33 is 0.2424. Right away, those are not the same, so these are not similar. I got one more here. Again, right away, I see vertical angles. I don't see any other angle pairs, so angle is out. In each triangle, I only know about the length of 2 of the 3 sides, so that means that side is also out. The angles that are congruent are between the pairs of sides that I know about, so I can see if side angle side works by doing 14 over 42 and 14 over 42, and we can really quickly see that those are the exact same fraction. So these two are similar by side angle side similarity. And so we'll name them PQR, and it doesn't really matter. We can say PCB or PBC. So there are a couple more I want to show you. We'll skip this first one. I want to show you how the reflexive property exists in this picture. I do have 2 triangles, even though it might be hard to see, so I'll highlight them. I have this big triangle, and then inside of that I have a smaller triangle. So I want to know if they're similar. Well, right now I see that I have one angle that's 44 and one that's 48. And so right away, I know that those are not the same. I don't know anything about angle C. I don't know anything about angle T. What I do know, however, is that angle S is in both of these triangles. And that's an example of using angles and the reflexive property. We've been using reflexive property only with sides, but it actually exists with angles too. And so right now, all we know about these 2 triangles is that this one pair of angles at angle S are congruent. We don't know anything else, and so we just sort of have to let it be. We don't know that these are similar, so we're going to say not similar. And let's try one more using that same property. So reflexive property shows up here. Angle B is in both triangles. So I'm going to mark it up with an arc. And then it looks like I know some stuff about the sides of these triangles. This side BK in the smaller triangle is 10, and this side in the longer triangle is 30. So I can write that ratio. This side in the bigger triangle is 18. This piece is 12. So if I subtract 18 minus 12, I can figure out how long this side is. 18 minus 12 is 6. So this side of my small triangle is 6. So let's see if these 2 fractions are the same. 10 over 30 is 1 over 3. 6 over 18 is also 1 over 3. Angle B is between those sides, so we have side angle side similarity here. And so we can say that triangle BCD is similar to triangle BKL. So I have something a little different for you. It's kind of similar to what we did in the past towards the beginning of the year. I have a link here. If you type it in your Google browser, there's 3 questions for you to answer as well as entering your name. Make sure you enter your first name first. Answer the question, submit it, and then put your tablet away.